Here's a fun puzzle. Using the digits 0 to 9 exactly once, create a 10-digit number where the first digit is divisible by 1, the first 2 digits as a whole number is divisible by 2, the first 3 digits as a whole number is divisible by 3, and so forth. So let's see how we can solve this. First, I already know the placements of 2 digits. This 10-digit number is divisible by 10, so the last digit has to be a 0. And the first 5 digits as a whole number is divisible by 5. So the 5th digit has to be a 5 or a 0. And a 0 is already here, so the 5th digit has to be a 5. Now, to be divisible by 2, 4, 6, or 8, your last digit has to be an even number. So I'm placing 2, 4, 6, and 8 in the 2nd, 4th, 6th, and 8th spots as potential digits. Meaning 1, 3, 7, and 9 are potential digits for the 1st, 3rd, 7th, and 9th digits. So where do we go from here? I'm going to look at the divisibility rule of 4, which says that the last 2 digits as a whole number is divisible by 4. So let's write down the possibilities. And here they are. Now I'm going to look at the divisibility rule of 8, which says that the last 3 digits as a whole number is divisible by 8. So let's write down the possibilities there. And here they are. And I made sure that I didn't duplicate any digits over here. Now I noticed something. I noticed that 2 and 6 are the only options for the 4th and 8th spots. So 2 and 6 have to be in the 4th and 8th spots in some order. Meaning that 4 and 8 have to be in the 2nd and 6th spots in some order. So we can eliminate some options. Now let's take a look at the first 3 digits. A number is divisible by 3 if the sum of the digits is a multiple of 3. So let's write down what works here. Next, let's take a look at the divisibility rule of 6, which is a combination of the divisibility rule of 2 and the divisibility rule of 3. So we don't have to worry about the divisibility rule of 2 because this is going to end in a 4 or an 8. So let's focus on the divisibility rule of 3. We already know that the first 3 digits will add up to a multiple of 3, so we don't have to worry about that. So let's just make sure that the 4th, 5th, and 6th digits add up to a multiple of 3. And we only have 2 options that fit that requirement. Now, let's connect the 4th, 5th, and 6th digits with the 7th and 8th digits, and make sure that there are no duplicate digits. And here they are. Now we have a list of potential 1st to 3rd digits and 4th through 8th digits. Now let's put them together. Let's make a list of potential 1st to 8th digits, making sure that we do not have duplicate digits. And here they are. Now I'm going to take a look at the first 7 digits as a whole number and divide by 7 to see which of these is divisible by 7. And only one of these is divisible by 7, so we found our answer. So we used the digits 0, 1, 2, 3, 4, 5, 6, 7, 8. The only digit not used is 9, so 9 belongs in the 9th digit. So we found our answer. It's 3,816,547,290. So there's exactly one number that fits this requirement, and I think that's really cool.